Section 7.3 Estimating a population standard deviation or variance. Okay, in this session, we want to construct the confidence interval for standard deviation or the variance. And for the standard deviation or variance, we will be using the chi-square distribution. Okay, chi-square distribution. Let's review a little bit on section 7.1 and section 7.2. Section 7.1, we're talking about confidence interval for proportion. Okay, the P stands for the proportion. And then we're gonna use the Z distribution. Section 7.2, we do have a two-part. First part, confidence interval for population mean. And this is when they given population standard deviation. Okay, then we're gonna use the Z distribution also. But then second part, confidence interval for population mean. This time when they given the sample standard deviation, okay, sample standard deviation, then we will be using the T distribution, okay, the T distribution. And section 7.3, confidence interval. We have for population standard deviation or the variance. And that will be using the new distribution. We call that a chi-square distribution. Okay, that will be the chi-square distribution. And okay, for the Z distribution, we will have the normal distribution, right? And then we say in the middle, that is going to be the 0, and there's a 1, 2, 3. The C's got -1, -2, and -3. Okay, so this is the Z distribution. But for the T distribution, we have something similar. We still have the normal distribution, but it's going to be more spread out compared for the Z distribution. And it also depends on the degree of freedom. The degree of freedom, n-1. If you keep increasing the degree of freedom, it's gonna be approaching to the Z distribution. Okay, the red one is like, for example, this is a degree of freedom is equal to 10. Okay, the blue one here, I would say the degree of freedom may be equal to 1. Okay, like that. So if you increasing the degree of freedom, the T distribution, it will be approximate to the Z distribution. Okay, so this is a T or Z distribution. Okay, now we're gonna talk about the chi-square distribution. Chi-square distribution, this is not symmetric. The distribution, they will be skewed to the right. Okay, skewed to the right means like the white tail is longer. And then you can see they're starting from the 0. Okay, 0, 1, 2, 3, 4. So that's a no negative numbers for the chi-square distribution. Okay, this is the chi-square distribution. They are not symmetric, skewed to the right, and also is always greater than or equal to 0. Okay, they never has a negative number. And they also have the degree of freedom equal to n equal to -1. Okay, and the chi-square distribution, we will use the cumulative area from the right. Okay, so when you calculate the area, that will be cumulative from the right to the left. Okay, so look at the PowerPoint here. Okay, skewed to the right, unlike the normal and the student T distribution. And chi-square is always greater than 0 or equal to 0. They're never negative. Okay, keep in mind, they're never negative. Has the number of the degree of freedom increased, chi-square distribution approach a normal distribution. Okay, normal distribution here means like the z distribution. And also the chi-square distribution is cumulative from the right, okay? And then look at this picture here. This is the chi-square distribution when the degree of freedom equal to 1. If we increase the number of the degree of freedom, like here, degree of freedom equal to 5, it's going to be coming like that. Equal to 10, equal to 20. You could see if you increase the degree of freedoms, that will be approaching the normal distribution also. Okay, but when it, even though it's approached to the normal distribution, it's also still greater than equal to 0, okay, or never negative. Okay, then we need to know how to find the critical values. The critical values, that will be similar to the 7.1 or 7.2, okay? But to finding the critical values for the standard deviation or variance, you have to use the calculator. And the calculation is pretty complicated, okay? So you're gonna follow like this step here. Let's try in one example and then we're gonna go back for here. Okay, find the critical value. Find the critical value for 95% confidence interval using the chi-square distribution with the sample size of 11. Okay, I have the sample size n equal to 11, and then I want to construct the 95% confidence interval. So first, n equal to 11. So you know the degree of freedom, that will be n minus 1, which is equal to 10. And then keep in mind, this is not a normal distribution, okay? Should be skewed to the right, okay? And has to be positive. So first, 95%, that will be talking about 0.95 in the middle, okay? We assume we do have a same area for the left tail and also the right tail, okay? So 0.95 is the area in the middle here. Now, we will look for the alpha. Alpha, that will be 1 minus 0.95, right? 1 minus 0.95, and then we're going to divide it by 2. So when we divide it by 2, we can find the area for each tail. So that will be 0.025. Okay, the procedure is pretty similar to 7.1 and 7.2. Find out the area for each tail. And now we're going to find the critical values. For the critical values for standard deviation and variance, we do have two critical values. One is a chi-square to the left, one is a chi-square to the right. Okay, let me use the picture to write down it. Okay, so we have the picture like this. This is a 0.95. And then we find out the area for left tail here. That is a 0.025. Okay, 0.025. And then we're gonna look for like this critical value. We call that a chi-square to the left. Okay, chi-square. That's a chi-square to the left. That's L in here. So what we're gonna do? Get your calculator. Okay, calculator. Look at the step in here. Let's do it like one by one. Okay, first, you're gonna go to the math. The math is gonna be under the alpha here. Go on the math, and then you can use the arrow go up. When you go up, you're gonna find the solver. Okay, the solver. Okay, enter. So you're gonna see equation colon 0. Okay, equation colon to the 0. Okay, and here I'm gonna go to the second click on second, vast, and then go down, you're gonna see chi-square CDF, okay, chi-square cumulative area, enter. And then you're gonna plug in the three numbers in here. This is like 0, comma, and then the x, that will be next on the stat, okay, the stat here, you could see x, t, theta, and n, okay, click on this x, and then comma, and then degree of freedom. We have the sample size n equal to 11, so degree of freedom that will be equal to 10. Okay, and then we're gonna do minus, okay, minus the area to the left. Okay, look at the picture here. This is talking about I want to solve the equation. Okay, that's equal to 0. The cumulative area starting from 0. Okay, starting from 0. 0 at this point until the x. The x means like the chi-square to the left, comma, the degree of freedom, minus the area from the left. Area from the left is talking about here. That will be 0.025. Okay, one more time. This is talking about solving the equation. I set up the equation equal to 0. Cumulative area starting from 0 until at this point, chi-square to the left. And then degree of freedom minus area from the left. Okay, minus area from the left. That's a 0.025. And then enter. Okay, you could see the screen look like this. And then you're not done yet. Once you see x equal to 0 here, you're gonna press alpha. Alpha is gonna be under the second. And then enter. Okay, you can see there's a bar is running on it. So wait a minute. Now I'm gonna get it. It's gonna be 3.25. Okay, 3.25. That will be my critical value. Or 3.27. Okay, let's take one more decimal space. 3.247. So here, my chi-square to the left, that will be 3.247. Okay, I could write like the whole thing in here, just like the PowerPoint. Here, chi-square to the left, that will be equal to equation chi-square CDF 0, x, 10. Okay, this is one more time, starting from 0 until the x. And then comma 10, that will be degree of freedom, minus the area from the left. Okay, you're gonna get 3.247. Okay, now let's try to find the critical values on your right. Okay, let me use a different color. So this point, this is gonna be my chi-square to the right. Okay, we need to look for this guy. Okay, let's have another picture here. Okay, we know the area on this white tail, that is a 0.025. So, and this is what we're looking for, chi-square to the right, chi-square to the right. So here, you know the cumulative area from the left, that will be 0.975. Okay, talking about from the 0 this point until here, the cumulative area, that will be 0.975. Okay, go back to your calculator. One more time, go to math, go up, solve now. And then once you get this screen, be careful, use the arrow button, go up. Okay, go up. You're gonna go back to this screen. Equation 0 equal to chi-square CDF, starting from 0 to x, degree of freedom. You only need to change the area from the left. That will be 0.975. Okay, enter. And then once you have x equal to, click on alpha, enter. Okay, you could see they're running on it. Now you find there's a 20.483. Okay, so the chi-square to the right, that would be 20.483. So we have two critical values on the section 7.3. Okay, if you want to try one more time, if you click on math, go up, get the softener, you're gonna see this screen. Be careful, don't start working on it here. Go up. If you want to delete everything and start it up again, click on delete. You have to, or click clear. Okay, click clear. Okay, once you have the equation colon 0 equal to, now you could do second vase. Go to the chi-square CDF, starting from 0, comma, x, comma, degree of freedom, minus the area from the left, that will be 0.025. Okay, enter. And then click on alpha, enter. So this is gonna be the chi-square to the left, 3.247. Okay, do the same thing for the right. You could just go up. Only need to change the area from the left, 0.975, enter. And then alpha, enter. Then you can see there's a 20.483. Okay, that's a chi-square to the right. Okay. So you guys could get that. This is a chi-square to the left. I just wrote it down. What did I put on my calculator? Okay, so what did I got it? Chi-square to the left, that's a 3.247. And then chi-square to the right. Okay, I only need to change the area from the left, that's a 0.975. And that will be 20.483. Okay, so this is the step how you guys find out the critical values. And make sure try it on your calculator. Okay? Okay, this is the first step. How you find the critical values. And then we need to know how to construct confidence interval for the standard deviation or the variance. First, verify the requirement. Sample has to be a simple random sample, and the population must have normally distributed. Okay, we don't care about the sample size. Even though your sample size is greater than 30, but if your original population is not normally distributed, we can't construct the confidence interval. Okay, find the degree of the freedom, okay, n-1, using n-1. And then use your calculator to find out the critical value, chi-square to the left and chi-square to the right. And then construct the confidence interval. Make sure chi-square to the right is going to be on your left-hand side. Okay, this is the n-1 times the sample variance divided by chi-square to the right, and this is divided by chi-square to the left. Okay, what you guys found it from the step 1, you need to plug into this formula. And also depends on the questions. Are they want to construct confidence interval for variance or standard deviation? If they need to find the variance, this formula is good enough. But if they want to find the standard deviation, after you guys get this number, you need to take the square root, okay, for both sides. And then at the end, you need to know how to draw your conclusion. Okay, let's try one example. Or I could write down the step in here, just like in class. Okay, section 7.3, confidence interval for variance or standard deviation. Okay, we're gonna use the chi-square distribution. Okay, first, find out the degree of freedom, n-1. And then find out the critical value, chi-squared to the left, chi-squared to the right. Second, plug into the formula to construct the confidence interval. Okay, and again, this is for variance. If you guys looking for the standard deviation, you're gonna take the square root for both sides. Okay, take the square root if you're looking for the standard deviation. And then at the end, draw the conclusion. Okay, let's try one example. Construct a 99% confidence interval for the population standard deviation if a sample size 23 has a standard deviation equal to 12. Okay, so we have the sample size 23, and you know this is for sample standard deviation. Okay, that'll be equal to 12. Okay, first, n equal to 23. What is the degree of freedom? That will be -1, right? 22. Okay, now we're going to go for the first step. We need to find the critical values. So I have the picture here. I know in the middle there was a point 99. I find out the area for each tail. Okay, you're going to find 0.005 for each tail. Okay, now I want you guys try to find the critical values to the left and also the critical values to the right. Okay, use your calculator. Okay, so you guys should get 8.643 and find out the area cumulative from the left. That would be 0.995, right? So the chi-square to the right should be 42.796. Got that? Okay, let me show you guys one more time for the calculator. Okay, calculator. Okay, let me do it again. So first, go to the math, go up, get the softener. And then if you see the picture like this, make sure use the arrow button, go up, go back to tier. Let us start from the beginning, so I click clear. Okay, you should see that equation 0. Then go on second bars, go down for the chi-square CDF, starting from 0, comma, x, comma, the degree of freedom, that will be 22. Okay, minus area from the left, that's a 0.005. Okay, enter. And then click on alpha, enter. You could see they're running on it. You can see the chi-square to the left, that would be 8.643. Okay, 8.643. Now we're gonna find the critical values from the right. So again, I'm already in here, so I could just go up. I only need to change the area from the left. That would be 0.995. Enter. And then click on alpha. Enter. Okay, that will be 42.796. That will be the critical values to the right. Okay. Okay, so this is the first step. And the second, we're going to construct the confidence interval. Make sure with the question carefully. They want to construct the confidence interval for the population standard deviation. Okay, that's a standard deviation. Okay, now let's plug into this formula. Okay, plug into the formula. You should get this. Again, if they're looking for the variance, you could just stop it in here. But now we are looking for the standard deviation. So we're gonna square root for both sides. Okay, take the square root for both sides. So this is my 99% confidence interval for the population standard deviation. And then draw the conclusion. Okay, and then example 3. Okay, I want you guys try find the degree of freedom, critical values to the left, and critical values to the right first. Okay, you have sample size 22, so degree of freedom is going to be 21. Okay, you don't have to draw the picture. Okay, I only need this two on your exam. Okay, write it down. This one, how you plug it in on your calculator, and what did you guys get? So this is the critical values to the left, critical values to the right. And then plug into this formula to construct the confidence interval. Okay, plug into the formula. Okay, again, they want to construct the confidence interval estimate of the variance. Okay, that's a typo in here. Should be a variance of the population. So I don't need to take the square root for both sides. This is gonna be my final answer here. Okay, and then conclusion. Okay, that's it.